Okay, welcome everyone to the Live Peers quarterly transcoder and node operator focused community call. We do these once a quarter, and we kind of rotate them through month to month with this, or general project update, and then a topic focused call. So there's a call every month, but once a quarter we focus one specifically on the needs and interests of those running nodes and infrastructure on the Live Peer network. And typically there's a topic or two that's shared in advance. People might be presenting or sharing something specific, but it's really meant to be a conversation. It's meant to be a helpful resource to those running nodes to discuss issues with one another, surface issues and prioritizations to the people working on it, so we know what to focus on. And there's plenty of time for Q&A, so it can go wherever the community wants it to go. Note that we are live streaming it to livepeer.org/TV. And we're also recording it, and we'll upload it later to the livepeer.org website, so it can be a good resource for those who didn't get to watch and participate in the call. Cool. Okay, so for today, just as a reminder, Piers Mission, we're building the world's open video infrastructure. That's a big, ambitious, many-year mission, but what we've started with is this open source media server that you're all running on your nodes, and video transcoding, or the compute-heavy video processing-centric tasks that are really expensive for users who have many streams of video, and our open marketplace that lets all of our node operators compete with their GPUs to provide that work creates a really cost-disruptive and reliable global infrastructure that video developers use to power their video applications. So just in the context of the bigger picture, this network is super powerful. It's the basis for an open video infrastructure for the world. Today it's doing transcoding. We're looking forward to adding more types of jobs on top of that are video specific that can also leverage these GPUs, as well as bandwidth specific jobs, like maybe even peer-to-peer content delivery assistance in the future. So more exciting jobs and hopefully income opportunities for node operators to come in the future. Cool. So the agenda for today's call is to touch on some topics that have been kind of interest in the past couple of months. One thing we see discussed a lot is the work selection algorithm, and helping node operators understand who's getting selected for work, why they're retaining work, and if they're not getting selected for work, why that might be. Another topic that comes up a lot is this notion of earning money and getting payouts. And we have this probabilistic micropayments mechanism. It's not conventional. It might be a little hard to wrap your head around. It's working pretty nicely in terms of enabling gas-efficient transactions, but creates some confusion. So we have an opportunity to explain how that's working and clarify issues we've been seeing with that. And then I want to touch briefly on gas estimation, some fluctuating gas cost impacts that we've seen on the network, and then plenty of time for Q&A as well. Cool. So before diving into work selection, just a quick overview of what's going on in the network. I think everyone's noticed we've hit some pretty exciting milestones. 2 weeks ago, we set a record, an all-time high, 1 million minutes of video ingested into the network for transcoding over the course of the week. And then the last week, we surpassed that, and we hit 2 million, actually. So this is really exciting. We're on the right track. We're growing. A lot of this has been driven by onboarding new users through the livepeer.com API, which puts kind of a nice gateway interface onto the LivePeer network and uses the LivePeer network for transcoding under the hood. I think, to set expectations, I think in the early days, this usage will be a little lumpy. A big new user comes on, we see a lot of growth. Hopefully they can grow over time as well. But, unless you're continuously onboarding new users in a ongoing way, it might be a little lumpy where it goes up, it's down, it's unsmooth. Very normal in the early stages for any technology product, and over time through more adoption that should smooth out. Fees have gone up in corresponding to this increased usage. It's interesting. I took the screenshot today. It actually shows red, and it shows kind of a drop in 7-day fees relative to this exact moment last week. But overall, the last couple of weeks, I think we've been around that. I forget what it was, $6,000, $7,000 in fees, $10,000 in fees, on track for 8,500 or 8,600 this week. So definitely promising and up relative to where the network was. I think this, when you do the math on these numbers, it's been equating to a little under 30 cents an hour for transcoding. I think that is on the public network. I think that is definitely disruptive to other cloud providers that are charging $3 an hour for transcoding. But I would actually expect the cost per hour to come down as nodes get more competitive, as there is more scaled work. That's really great income, but I think it'll probably get more competitive as scaled operators are willing to do it for less, still in a highly profitable way over time. Cool. And then just real quick on the right here, I've showed how many current mintable tokens there are each round in the protocol. Right now there's 44,193 new live peer tokens being generated each round that are being distributed to node operators and delegators that call reward. One of the things about this that we can't wait to address via scaling is to make these reward calls more cost effective gas wise, so that more node operators can call reward every day and participate in this kind of ongoing token distribution, get live peer tokens in their hands, become more staked on the network. That's been one of the more painful things about high gas prices on Ethereum lately. But the prices have come down now, so more nodes have been calling reward, and hopefully with some of the layer 2 scaling research that's going on, it's not far off from getting that really cost effective. So a little bit more of an update on that later. The last thing to give a brief update on with kind of the current state of the node operator pool is we have a full active set. We have 100 orchestrator nodes with stake that are active on the network. This is kind of the view of nodes 91 through 100. You can see it currently costs staking 4.56 LPT in order to kind of break your way into the active set. So it's still very accessible for anyone that wants to begin participating and trying this out. Can pretty easily get involved. If LPT and staking and running an orchestrator is still a barrier, you can always consider joining a pool like Live Pool and just run a transcoder. And I know I think there's over 100 nodes or 100 transcoders that are involved in that as well. So different ways to get involved, but still very accessible. And again, I think as we focus on scaling solutions, we can expand this number well beyond 100 if that's what the community wants to do. And there's actually that many nodes that are adding value to the network. Cool. Okay, so I'm going to jump over to work selection. But before I do, does anyone have any questions or comments on what I just shared related to fees, growth, orchestrator set? Nope. Cool. Okay, so work selection. What I did is I mapped out a couple of questions that we want to answer that I've seen in the community lately. We can have a discussion and talk about these. The first one is, how does the work selection algorithm currently work? We see that one a lot. And I'd like to hand it over to Yandin, who leads the protocol engineering, to kind of elaborate on this question.
Sure. So I have just a few small slides that I'll share, just so that we can walk through them together. And if I can share my screen. All right, can people see my screen?
Yep. Yes.
All right, so cool. So work allocation / selection. The two things that I'll focus on here are just what we mean by work selection and work allocation and what we're trying to accomplish here. And then I'll talk a little bit about how it currently works today. So within the live peer network, in contrast to, say, a typical proof of work mining network or proof of stake validation network, there isn't a single protocol defined work allocation algorithm. So it is not the case that the protocol is going to decide how work gets distributed to the orchestrators on the network, but rather the decision-making process for how work is allocated and how orchestrators are selected is pushed to the broadcasters. So the nodes on the network that actually require these services. And broadcasters are going to select orchestrators based on their own preferences. So they may have so one broadcaster might have one set of preferences, another broadcaster might have another set of preferences, and that's going to influence how they make selection decisions. So broadcaster A may select orchestrators in a different way than broadcaster B. So the work allocation / selection algorithm is going to depend on the broadcaster implementation. So what is the broadcaster node implemented to do? That's, in theory, how it works. But of course, there's a default implementation in the Go Live Peer software. And this default implementation we'll talk a little bit about momentarily. But unless someone makes implementation changes to the node, a broadcaster would use that default implementation that's currently supported. In the future, the vision at the moment is that broadcasters will be able to more easily express their preferences. So regardless of what your preferences look like and how you want to prioritize certain orchestrators, you'll be able to do so really easily. It's not quite that easy today, which is why there's so much importance in the default implementation. But the hope is that going forward, if preference expression becomes easier, then there's less reliance on the default, and broadcasters will be able to select based on what their own appropriate needs are. So some of the considerations that go into selection today are, the two big ones are economic security. So this can be measured via the total stake of an orchestrator, as well as latency. So generally, when we say latency in the context of the live peer network, we refer to the time to receive transcoded results. So starting from the moment that the broadcaster sends off a video segment from a stream and ends when the broadcaster actually receives the transcoded results from an orchestrator so that those results can be used in an end user application. Those are the two main factors that are considered today. And there's definitely a few other factors that could be considered in the future that I'll just mention a few examples here. And if people are interested, we could talk about later in the call. But other information that's available on the network includes fees earned by orchestrators, as well as self-stake versus delegated stake. So that information could certainly be used as a part of selection decisions. And another one is reputation. So an orchestrator being able to build up a reputation over the course of many interactions on the network. So those are factors that are not considered today, but could be considered in the future. So let's get into the default implementation, since we mentioned earlier that while broadcasters are able to express their preferences via their selection implementation, the default is pretty powerful. So how does the default work today? The way that it's broken up is there are two phases. So the first phase we call the discovery phase. So this answers the question, which orchestrators should be considered for selection in the first place? And the second phase is the selection phase. So once you have discovered a set of orchestrators, which of those orchestrators should be selected and in what order? These phases are run per stream. So for each stream, a broadcaster would run the discovery phase, followed by the selection phase. And the discovery phase roughly follows this basic outline, which is the broadcaster is going to send these discovery requests to orchestrators, and it's going to filter out those orchestrators based on a few criteria. Examples include price, ticket parameters. So for example, you'll filter out an orchestrator that charges a price that's too high. And
just to clarify that,
yep.
a lower price doesn't help you get selected over one with a higher price if they're both below the price the broadcaster is willing to pay, correct? At
the moment, yeah, that's the case. There is no, as long as the the filter is only based on a maximum. So as long as you're below the maximum, there isn't any additional prioritization from there at the moment.
Right, but you could see in the future how an implementation might want to always select the lowest price node first.
Yeah, definitely.
Thanks.
So after the filtering process is complete, the last step of the discovery phase is that the broadcaster is going to take, at the moment, the first 8 eligible orchestrators to respond in order to construct what we call a working set. And once we have that working set, we move on to the selection phase. So the thing to note with the construction of the working set is that after the filtering process is done, the way that orchestrators are added to the working set, it prioritizes how fast you're able to respond to those discovery requests. So generally, if you're closer to the orchestrator, you're going to be responding faster to those discovery requests and have a higher chance of being included in the working set. After the discovery phase, we move on to the selection phase, and the selection phase at a high level follows this outline, which is the broadcaster is going to keep track of the last known latency for each orchestrator. So as if people recall, we treat latency as the time for the broadcaster to receive transcoded results for a video segment. So the broadcaster is going to keep track of the last known latency for each orchestrator. And using that information, it proceeds to do the following. If the orchestrator with the lowest latency transcoded the last segment in real time, we will use that orchestrator. So if the last orchestrator that you sent a segment to has been keeping up with the stream in real time, then the broadcaster is going to continue sending segments to that orchestrator. And we use real time as kind of the rough threshold, that rough performance threshold to base a lot of decisions off of, where we really want to be real time or faster. If there are orchestrators without a last known latency and the current orchestrator with the lowest latency is not transcoding in real time, this is where stake comes into play, where we use stake to determine who we should try next. So we will do a random stake-weighted selection of the remaining orchestrators to determine who we should try next. This is basically saying the last orchestrator that we tried clearly isn't keeping up based on the performance that we want. Let's try another orchestrator, and we use stake to determine which orchestrator to try next. So that's the second criteria. And then the last criteria is just that if all orchestrators have last known latencies already, and then we'll just select the fastest one available to us. So this is a basic overview of how the selection decision-making process works. There's a couple more details that we could get into later if we wanted to, but I think the thing to highlight here is that this initial default implementation is very quote-unquote greedy, where at any point in time, it just tries to make the best decision based on what it knows at this point in time. So that's a brief overview of the default implementation. And maybe I'll pause there because I know that, Doug, you wanted to cover a few other things. So I'll stop here regarding the default implementation, and I'm happy to talk about this a little further or answer any questions before we move on to other points that we wanted to get to.
Thanks, Jan. And so let's map that onto practice, right? So, understanding this deeply, what does it mean? It means that if you want to be assigned work, there's a couple takeaways. One is you want to be in one of the first 8 orchestrators to respond to these kind of discovery requests, or at least respond with the lowest latency, right? And then from there, the more stake that you have, the higher probability that you would be the first randomly selected to attempt to process the stream. And then as long as you continue to transcode the segments that you receive in sub real time, you would retain that work, right?
Yeah, I think that's a pretty good overview of how the practical implications, at least right now.
Right, right. And then mapping it even further, how do you become in the top 8 response times from those discovery requests? Well, there's a series of, like, livepeer.com is driving a lot of the streams and the work on the network right now. So it's the livepeer.com broadcast nodes that are making these discovery requests, and they're spread in several regions around the world, right? I think there's one in New York, there's one in Frankfurt, right? There's one in London, there's one in LA, there's one in Singapore. And so, nodes that are located around the world, as long as they have, a fast connection to one of these regions, have the chance to kind of be in the top 8 to respond. Are there other ingest regions that I missed? I mean, I think there's a full list available on the livepeer.org status page. Is that right?
Yep, there should be a full list on the status page. That's correct.
Right. And then a question is, let's say an orchestrator is busy transcoding other segments. Maybe they're falling to sub-real time. Is there anything that would boot them out of the set, even if they were one of, like, the first 8 to respond, but they weren't transcoding in real time? Do we seek to add new nodes into the set to give them an opportunity when nodes that are in the set are failing?
So at the moment, it depends on the type of failure. So if a node is just, say, transcoding slightly slower, so it is not quite transcoding in real time, then it wouldn't be rotated out of the working set. However, if the orchestrator is transcoding so slowly to a point that it hits the node level defined timeout, then that is a scenario where it would get rotated out of the working set. I don't recall what the timeout is set to right now, but I think the way to think about it is, there's this range where there's this latency range where the orchestrator will still, even if it's slower than real time, will stick around. But if it falls past kind of the end of that range, then it could get booted out of the working set. And in addition to that, other reasons why an orchestrator might be removed from the working set, giving other orchestrators the opportunity to get added, include just really any type of error. So if you happen to go offline in the middle of the transcoding, you would get removed. If you hit a timeout, you would get removed. If there is some network-related error, which can happen, just given that it's the public internet, if there's some network-related error, you would get removed as well.
Yep. And if you're removed, there's some time period before you would be potentially added back.
Yes. So it's the way that the removal happens is that it's time-based. So the intent there is just to give other orchestrators the opportunity to be tried as well. And then after that time period, you could be re-added again down the line.
Great. And then again, mapping this into practice. So, you might think, oh, the fastest node is always gonna get assigned the work and they're gonna retain it and I'm never gonna get a chance. But in practice, what do you see? Well, you see some of these broadcast nodes have many, many streams coming out at once, right? They might have 50 or 100 streams that they're trying to find orchestrators for. And there's a very common type of error that's returned, the orchestrator busy error, which is where there's just no sessions available. The orchestrator can't keep up in real time if it's busy, and that would right away kind of be an opportunity for that broadcast on that particular stream to identify another node and give it a chance. So in practice, you should see this work distributed pretty broadly across the set on the network.
Yep. One additional thing I wanted to add on here is that, so this is the way the default implementation works right now. And I think there's actually been some good discussion in Discord about the pros and the cons of the way the current default implementation works. And as I mentioned earlier, in the long term, we really want to have the default implementation become less and less important, because broadcasters are more easily able to express their preferences based on kind of the quality of service that they want and what they demand. But since the default implementation is important right now at this early stage, there's been some good discussion in, there's this good GitHub issue that Nico created highlighting how the default implementation works today, some of the pros and cons, and there are some good comments from other community members and node operators around what they see as working well about it and what they see as not working well about it. And I think the one thing that I would highlight, I'll drop a link to this in the chat afterwards, but the one thing that I do think is worth highlighting around how the selection or how the implementation works right now is this fact that it prioritizes the 8 first eligible orchestrators to respond. So that means that if you're not in that first 8, you don't have the opportunity to be selected, even if your response time was like 200 milliseconds and the other person that was included was like 190 milliseconds. You're kind of out of luck, at least in that first working set creation. Even if you happen to have, say, better overall hardware or better overall bandwidth, but they just happen to be slightly faster in responding, perhaps due to geographic proximity. So I think that was definitely something that we've identified as potentially harmful in terms of how the distribution works. So what I'd highlight is that there is ongoing work to explore improvements to the default implementation. So the main body of work here is there's this PR that's open in the Go Live peer repository that's experimenting with constructing a larger working set during discovery to give more orchestrators an opportunity to be even considered for selection, even if they're not the fastest to respond to discovery requests. So I just wanted to highlight that as an example of some ongoing work to see if we can make some improvements and updates to how the default works today.
Awesome. Thanks, Yandon. The one other question I wanted to highlight briefly is just, we get it a lot. Does staked LPT matter? Does the amount of LPT you have staked matter? And you see that today it is an input. This working set is constructed, and then the node's randomly chosen probabilistically based on how much stake it has. So more stake equals higher chance of selection. Why is that the case? Why does it matter? A lot of this does have to do with what we're working towards longer term, but your stake theoretically secures the work that you're doing on this network. This is an open, anonymous network. Any of these transcode nodes could theoretically attack it and misencode video and return improper video. There's a lot of R&D going on in the verification algorithms that the broadcast nodes can use to check against that and discard any improperly transcoded video. But there's also, in the original design and the intent, this economic penalty, this slashing that could occur, not for being too slow or being offline, but for maliciously misencoding video and returning the wrong type of content, for example. And the stake is the security against that. So again, it comes down to broadcaster preferences and their use case, but you could see certain applications that only wanted to work with nodes that had enough at stake that could be penalized and taken away if they maliciously attacked their application. And that's a really valuable, important property that we want to work towards ensuring. Right now, slashing is off. There's a lot of data being collected about the performance, about the reliability of the node that's coming out. No one is actively attacking the network that we've seen, which is nice, but ultimately it will become important long term. And I think if you think of stake as security, that is an input that this selection algorithm, whether default or by preference, should use. Cool. Okay. So I just want to open it up to questions if anyone has any questions or things they need clarification on this topic.
Yeah, I've got like 2 questions, but the first one is, so orchestrators with a large stake that aren't actually transcoding, is there, if in the discovery phase, if they get locked up into the working set, is there a chance that they would clog up that working set and not get removed, or how does that work?
I guess what would happen is they would have to be, they'd have to have a fast response time in the discovery period. And if they did, they could clog the working set. But the broadcast node would evict them from the working set as soon as they didn't return a transcode within the threshold timeout period. So they would be evicted. And I think you do bring up what looks like it could be a weakness or a bad scenario now, is that you could have a full working set of all nodes that weren't doing any work. And then on that first segment, you were trying to get transcoded. I don't know how quickly you would evict them all from the set, repopulate it with healthy nodes. And I wonder if that would cause a kind of delay in the start of your transcoding experience. Would be an interesting thing to test and defend against.
Okay, great. Yeah, thank you. And I guess if they were to clog it up, I guess because they get removed out. So eventually it would just move on to more qualified orchestrators. And I see that there's other nodes with large stake that just have arbitrarily high transcoding price, maybe just to keep them out of the working set to begin with. So they've also maybe have thought that through. The other question I have is when they calculate the stake for order, is it order based on the order at which you are in line, or is it calculated like the probabilistic of you getting the job based on the exact amount of stake that you have delegated?
So it's probabilistic, and so just to make it more concrete, you have 8 orchestrators in your set. And if one orchestrator's stake represents 20% of the total stake in that set, they would, roughly speaking, have a 20% chance of being randomly selected. And then if you have a higher share of the stake in that set, then probability increases, and vice versa if you have a lower share.
Great. Yeah, that answers it. Thank you.
Cool, great questions. Anyone else?
I think though, just one observation that I wanted to mention is that I think there's definitely a lot of benefits from allowing broadcasters to express their preferences and pushing the selection decision-making criteria to them, just given that in a network like this, different users are going to have different requirements, and it's really hard to define, say, a protocol level algorithm that can fit the requirements of every single possible user that'll come around. So that's definitely one of the benefits, but do want to acknowledge one of the downsides that exists today, that I think hopefully we can come up with tools and solutions to improve this situation, which is around transparency. So we've gotten a lot of questions about how the algorithm works and why nodes are selected in a certain way. And I think a lot of that comes from the fact that it is a little hard to understand because it could be different depending on the broadcaster. And it's not something that is transparent at the protocol level. So it'd be interesting going forward to think about ways that transparency could be improved in certain cases, just to give people a little better understanding of what they can do to improve their own performance relative to the way that nodes are selecting on the network. So don't have immediate answers to those questions, but I think that'll be a great great area to kind of come up with solutions in going forward.
Yeah, I'd also like, I think we should be cautious about trying to optimize too much to perform great on this current default selection algorithm, because we're trying to iterate and improve it and make it more reliable, and that may change, what you've optimized for and how useful that is. And also, this is, again, it's client implementation specific. So I think it's great if the network is more robust and there's, multiple broadcast clients, or people implement their own strategies for their own broadcasters that work differently. And there's a lot more sources of traffic than, the livepeer.com API just being the majority of the broadcasters. So you'll see a lot of different locations. And so I do think the things you really want to optimize for long term continue just to be like, good, strong internet connection to major internet hubs, reliable transcode capacity that can transcode in sub-real time, and, stake so that you have enough security behind your node. And if you optimize for those three things long term, then if you have a lot of diverse algorithms or strategies, you'll probably fit into most of them. Cool. Okay. Time-wise, we spent a good amount of time on that topic, which was awesome. But let's keep moving just to make sure we touch on the other things in the remaining few minutes here. Going back to my screen share. Cool. I wanted to hit on micropayments and how payments are working right now a little bit. Briefly, we've seen 47 nodes that have earned payouts, which is great. That's way up from last time we did this call. And under the current Ethereum gas conditions, we're seeing about 1.5% payment transaction fee overhead. I don't hold me to that number scientifically. I just sampled a couple of recent ones and did some back of the envelope math. But what that means is, if you're cashing in a $450 ticket, your price to cash that in is less than $10. The overhead you're paying is kind of less than a credit card processing fee. It's 1.5% in gas, and that's part of the design behind our micropayments mechanism, such that you do get paid in these bulk kind of lottery ticket type payouts, and you don't have to be submitting transactions and paying gas very frequently every time a user comes on and off and closes the channel, or every time you transcode a single stream, like was in the first design of LivePeer that definitely didn't scale. So the current payment mechanism is working as designed, but at the same time, I recognize a lot of people have been a little frustrated where they say, "Hey, I've been on this network for weeks or months. I haven't earned a payout yet. What's going on?" So I want to kind of ask a couple questions of the team and community and see if we can help give some clarity on that. So the first question I have is, how many tickets should I expect to receive before I am due for a payout? How many segments of video should I see transcoded? Yandin, have you done any back of the envelope math on that?
Yeah, so I've done a little bit of math on that. Unfortunately, it's probably a little too involved to express it all verbally here right now. So I'll just try to give like a high level summary, and I might link to a few resources afterwards. But in terms of how many tickets someone should expect to receive before being due for a payout, if everything was held constant, I think a way to estimate that would be for the ticket, it's going to have a face value and it's going to have a winning probability. And if you divide one over the winning probability, I believe should give you a ballpark estimate of how many tickets at the minimum you would expect to receive before receiving a winning one. So let's say that the winning probability was 2%. So 1 divided by 0.02 is 50. So that would, I believe that would mean you would roughly see at least 50 tickets before receiving a winning one. But I think this is a very rough approximation, and I think it could definitely fluctuate a lot just given the nature of randomness. But that might be a good just ballpark starting point. And I don't think this information is exposed in the Explorer, since it just highlights the lump sum payouts. And it just shows you like how much the face value of the ticket was. But I think that information is definitely available on Etherscan, so it'd be interesting to kind of use that information to make those estimates as well. So that's one thing. If everything was held constant, you could use that winning probability to give you a rough estimate of like the target number of tickets you should expect. And the reason I say everything held constant is that not so much lately, but we have seen like the face value and winning probability of tickets change, especially as gas prices fluctuated on Ethereum. So there's been a little bit more of a stabilization recently and lower gas prices. So we haven't seen that as much, but the orchestrators are programmed to adjust their ticket parameters based on the current gas prices that they see. So as a result, in practice, not everything is held constant, right? You might end up receiving tickets with a certain winning probability for a chunk of time, and then tickets with a different winning probability in a different chunk in time, which is why it's really like a very rough ballpark estimate. But I think that can be helpful to determine the number of tickets you should expect to receive, and then how that relates to segments of transcoding. At a high level, the way that a node determines how many tickets to send as transcoding happens is based on this accounting process, where I think most orchestrators are familiar with the fact that they charge a price per pixel. So they charge, say, like 1,000 Wei per pixel of transcoding. So what would happen between a broadcaster and an orchestrator is, if you are charging me 1,000 Wei per pixel, I will look at the amount of transcoding that's being done, and then the amount of pixels that corresponds with, to determine the kind of cumulative value for a segment of transcoding based on the number of pixels and the price. And then based on that cumulative value, I'll determine how many tickets to send you. So if that cumulative value, just for argument's sake, is say like 1 Ether, and the expected value of a ticket is 0.5 Ether, I'd send you 2 tickets. If the cumulative value is instead 0.5 Ether, I would just send you 1 ticket. So in that way, the price that you set is going to impact the rate at which you receive tickets. So higher price with all other things held equal would result in a higher rate of tickets received, and a lower price would, all other things held equal, would result in a lower rate of tickets received. So I hope that's a little helpful information, as I can try to provide links to kind of calculations that you might want to do yourself. But those are some considerations and some like ballpark estimates someone could get started with.
Yeah, thanks for the framework. So using that info you shared, anyone could, based on the price they're charging, calculate, how frequently they should get paid in terms of segments, and then from segments they could map it onto pixels. I did some back of the envelope math. I'm seeing these payouts in the $450 per redemption range, and I mapped that onto the approximate 25 to 30 cents per hour of transcoding that we're seeing, and I mapped that onto we're sending 2-second segments, and I think the math showed that you would expect to be paid for transcoding about 2.5 million segments of video, right? And what you might want to do is just look at, how many tickets am I receiving per segment, right? And from that you could do the math to get a ballpark of how often you'd expect to be paid out. Are the number of segments visible on the Grafana dashboards?
I'm not sure. It depends on. So I believe that they are available on some of the template dashboards that we've created, that the core team has created. But I think at this point, Virus and Numerous's community dashboard might be the most popular one, and I'm not sure if that information is included there.
Cool. Okay. And then the second question I had here, just briefly, we could touch on. We saw some ticket redemptions a couple weeks ago that were basically, they looked like they were $0 worth for each of these redemptions, and I think this had to do with kind of bugs in gas price estimations on nodes. Yeah, I don't think we have to spend a lot of time on it, but do you want to give just a brief overview on what happened there and whether or not this is addressed?
Yeah, so basically, as I mentioned earlier, orchestrators are the ones that set the ticket parameters, and they'll adjust them based on what they think the gas price on the network is right now. So they're dependent on the Ethereum node that they're talking to give them an estimate of what a reasonable gas price would be. And that worked fine for a while. But interestingly, the gas price estimates that you get back are based on a certain algorithm that's implemented, say, in like Go Ethereum in Geth nodes. And it depends on looking at transactions that have been included into blocks recently. A wrench was kind of thrown in this in the past couple months because basically there's been a uptick in the number of transactions that have been mined on the Ethereum network with super low gas prices, like 0 Gwei or 0 Wei or 1 Wei gas prices. And this is a whole separate discussion, but a lot of those transactions come from this project called Flashbots, that if anyone is familiar with that, but separate topic. But basically, there's been an uptick in those types of transactions, and basically the Geth node algorithm couldn't handle that very well. And as a result, when it would give you an estimate, it would think, oh, there's been a bunch of transactions included on the network for free or for 1 Wei. So I'm going to give you a gas price estimate that's super low. And then the orchestrator is going to see that, and it's going to think, oh, wow, the gas price is super low. So I can use that information to adjust my ticket parameters accordingly. And a few more details here, but basically this resulted in the orchestrators advertising ticket parameters with super low face values. So it actually wasn't 0, but it was close to 0. And yeah, this led to a few headaches. This led to the low value ticket redemptions that were mentioned. And we've been working to address this in a few stages. So the first thing that we did was we addressed the first thing that we did was we added a little bit of filtering logic on the LivePeer node itself to better handle this situation. And we're also currently working on just adding a few additional like safeguards, just in case if someone is still using an older version of an Ethereum node that still has this problem. So I think this has largely been addressed, but there was a few additional edge cases that popped up in, say, like the past 2 weeks, and we're currently working on some additional safeguards to cover those edge cases as well.
Great. Yeah, thanks for the overview. So yeah, if gas prices were truly that low, the node operators could cash in tickets all the time, right? You could get paid every time you do a couple of segments and value would just accrue. And that was the root of the problem here. Nodes thought the gas prices were low, so they were trying to cash in frequently at low cost, but it was, at the end of the day, it was costing them more than they were earning. So good bug to catch, to fix. It's great that the community like points these things out the second they happen, so we can get updates out quickly. All right. Only a few minutes left, so I don't want to spend a lot of time on the last topic here. I think we already talked about the impacts of improper gas estimations. The fluctuating gas prices have always affected people's ability to profitably make the reward call each day to kind of distribute and earn the LivePeer token that we want all node operators to be earning in order to become stakeholders in this network and be able to secure their work. I think that this relates to the layer 2 scaling research that's going on with the goal of dramatically reducing the prices that are necessary to call reward to make it profitable to do, even if you don't have a lot of tokens staked. In the meantime, I would definitely urge people who are performing well on the leaderboard, who are earning fees, to do just a little bit of campaigning or marketing, if you will, highlight how your node is performing, making people know you're available for staking and you have a reward cut, you're sharing some value back, and hopefully that allows people to shift some stake over towards you. If this network were really efficient and everyone could move stake around with the click of a button instantly without paying a high gas price, then I think stake would very quickly flow towards nodes that were performing well, in order to participate in the fee share, help secure the work and help the network. And that's the state that we're working towards. But in the meantime, kind of that lightest bit of marketing is welcome. And I think the forum is a good place to do that. And, I know some people pushed back on the marketing and self-promotion in the Discord, but I think we should figure out the healthy way where it probably is okay to highlight it in the Discord without, channels being flooded with self-promotions. Maybe that is a channel for promotions, or maybe it's okay in the bonding staking channel, for example, where delegators are looking for information to stake. So I'll kind of let the community come to consensus on the best direction for that. But I think in the meantime, that little bit of node self-promotion is okay and necessary until we have layer 2 scaling in place. Cool. I don't think we have time for a full update on that layer 2 scaling and research, but you should just know it has been a top priority in the last couple of months. There are candidate paths to explore that are being prototyped, and I think in the next 2-3 months we'd certainly want to be seeing if not major progress, at least test networks that people can participate in that show a promising path to the future there. Cool. So a couple minutes left. I'll stop presenting and ask if there's any questions or topics we didn't cover that people want to discuss, or questions on what we have discussed.
I have a question about something that we didn't discuss today.
Great.
The question is about benchmarking GPUs and benchmarking multiple GPUs on one machine. The current benchmarking program that we're running doesn't seem to maybe allocate the work properly amongst the GPUs when running multiple in the benchmark. Is that something that maybe that's an operator error on our side, but if you benchmark them each individually, you get a good result. But when you try to benchmark them all together, by adding up all the sessions that it's capable of, it's not. It's just throwing out of memory errors. Is that something that anyone has experienced, or?
Yeah, so it's not that surprising to me that I have trouble recalling the details right now, but it wouldn't be that surprising to me if multi-GPU using the benchmarking tool doesn't work particularly well right now. But I would say that the node itself, so not the benchmarking tool, but the node itself, when multiple GPUs are being used, does implement this GPU load balancing process so that it tries to at least more efficiently allocate incoming work to those GPUs depending on the load each GPU is under. But the benchmarking tool does not use that right now. But the benchmarking tool could use that. So given that it's not using that right now, it wouldn't be that surprising to me if the results look kind of funky with multi-GPU, which is why I feel like it's a little more useful to benchmark the GPUs individually if they're a mix of different GPU types, at least right now. But I think adding the load balancing feature might help there.
Yeah, it might be a good candidate to just open a issue on GitHub, and that might even be a good bounty opportunity for someone in the community to take on extending the benchmarking tool.
Great. Yeah, it's good to know that when the node is live that it's properly working, but just for the benchmarking process, it's just hasn't been implemented or it's just different.
Mm-hmm.
That's good. No, I appreciate that. Thank you.
I also have no doubt like there's room for improvement in how the node works and load balances as well, right? Like better predicting capacity management across the GPUs. So rather than, getting to the point where you receive an error, it can manage its own capacity based on the resources available. And I know there's going to be plenty of optimization opportunity over time.
Great. Thank you very much.
All right. Well, it looks like we're at the end of an hour here. Hopefully that was really helpful information. I've been really excited to see all the activity on the transcoding channel in the Discord and the Orchestrator Payouts channel. I think everyone is really helping one another, recognizing like we're still in the early days here. There's so much video out there in the world that we have the opportunity to put on the network. So even more importantly than like competing with one another for fees, I think it's like a rising tide lifts all boats scenario where we can make this network really, really useful and this software really good. It'll help us onboard a ton of work, a ton of capacity, a ton of fees in the future. So thank you to everyone here for participating in that and being part of this big ambitious journey. A lot of fun, but a lot of work ahead of us for sure. Cool. We'll stop the recording. We'll put the video up online for those who couldn't join, and we'll see you in the Discord and on the next call. Take care.
Great job, everyone. Thanks.
Thank you.